Hello and welcome to the Groome Industrial Service Group presentation. We're excited to participate in the RefComm virtual conference this year. Today we'll be reviewing Groome's refinery maintenance services with the goal of finding value for your facility. Stop by our booth anytime if you've got questions specific to your plant. Groome has a long list of specialized services focused on improving efficiency at your facility. To start off, let me give a brief introduction on what we do. We're specialists and leaders in emission catalyst systems, the SCR or NOx catalyst, for example, and the CO catalyst. Lifecycle management services include testing, evaluations, online cleaning, offline cleaning and repacking, replacement, disposal, reclamation, retrofits, and more. You can't discuss the SCR without the ammonia injection grid. Groome offers AIG cleaning, tuning, and permanent sampling grid installation as well. Efficient heat transfer and cooling are also crucial to a plant. Groome utilizes foam and dry ice for fin fan and fin tube cleaning. Additional services include water jetting and painting. Groome has been in business for over 50 years. We complete our projects turnkey and cater to work in the refining, petrochem, and cogen power gen spaces. We've grown our business by adhering to a simple philosophy: provide quality, innovative services at a reasonable cost. Don't turn your back on safety. That's our philosophy from our headquarters offices to the job site trailer. This top-down approach ensures that we all practice what we preach and result in fewer accidents and higher productivity. A safe project starts with prevention. Hazard identification is always a primary focus for our team to prevent injury. Efficient NOx reduction is only possible through a properly designed, installed, and maintained SCR catalyst system. Pollution control continues to show escalated importance. Permits on NOx and ammonia are tight and will prove to get tighter in the coming years. There are many reasons the system can be pushed out of compliance. Some of the popular ones include system upsets, design flaws, different expectations or running parameters on your system, stricter permit levels, the wrong grade of ammonia was delivered, and more. Understanding these factors and what to look for are important in order to provide proper corrective action. Not all SCR catalyst systems are created equal. Also, not all cleaning practices are created equal. In the before picture, you'll notice that the issues with the catalyst include a masked face, insulation between the bricks is blown out, and the blocks are shifted. In the after picture, the blocks are cleaned from the downstream to the upstream. The face is cleaned, the blocks are repacked and realigned, and new insulation is installed to prevent slip. This plant is now set up for success to run smoothly until their next turnaround. Proper maintenance must consider all 10 factors of the SCR life cycle. It's commonplace, unfortunately, to think of the SCR life cycle as a two-step process, which is most commonly clean and replace. This could not be further from the truth. Taking all the appropriate steps will yield favorable results in many respects, including maximized flow through the catalyst, maximized catalyst life, minimized pressure drop, exposing conversion sites, improving efficiencies, and reducing ammonia slip. There's a lot of detail here on the steps and details of the SCR lifecycle maintenance. Please stop by our booth to review these in detail, or we'll do this just for the sake of time, as every unit has its unique needs. There's some additional detail on SCR maintenance and the CO catalyst. We'll get into that now. CO catalysts aren't as common in the refining space, but if you've got one, we've got answers. Feel free to stop by our booth and ask. System evaluations are a crucial step in any catalyst lifecycle. Completing a proper evaluation gives our engineers and yours the data that's needed to factor catalyst activity, unit performance, catalyst end of life, and more. All these factors are used to determine the most beneficial plan for your plant. The CO catalyst lifecycle is not as complex as the SCR, solely because we don't have a need for ammonia with the CO process. There are unique factors to consider with the CO catalyst though. First off, in situ cleaning versus washing. Washing alone has its own options, including acid, heated acid, and more. A proper catalyst analysis will determine what type of cleaning will add more life to your catalyst, so you can weigh the cost benefits. You also must consider reclamation when you do have to replace your catalyst, as there's a lot of precious metals, be it palladium or platinum, that's left over in that spent catalyst. As part of the turnkey service, any replacement project includes catalyst disposal as well. Groome processes the paperwork for your plant record keeping. The catalyst steel is recycled. The catalyst itself is deconstructed to take up less space in the landfill. This is all after a T-clip is performed to document that there's no hazmat issues. Your AIG is crucial in the effectiveness of your SCR. We'll get back to talking on the SCR balance here. If ammonia isn't being distributed evenly across the face of your SCR, then a large percentage of your SCR just isn't working for you. A proper tuning will calibrate your AIG to put ammonia where it needs to be for conversion and to minimize slip. Tuning should not be completed without a cleaning beforehand. It's extremely important to tune off of a solid baseline. You wouldn't wax your car without washing it first, so don't tune it. Don't tune your AIG without cleaning it first. Here's a great visual of what tuning can do for your system's efficiency. The red spots on the left show where there's high ammonia slip. Note that the valve positions on all the zones on the left-hand chart are in the 5 o'clock position. This is before tuning. Very important to note here that an even valve orientation does not equate to an even ammonia distribution. After just 3 valve tuning adjustments, the graph on the right shows a 58% ammonia slip improvement. Note that the valve orientation on the 3-step tune process ranges from 3 o'clock to 8 o'clock. To maximize ammonia distribution and tuning efficiency, a permanent sampling grid might just be a great investment for you. Traditional tuning utilizes glass probes, which are prone to breaking. They're limited to the number of testing positions, and it is a labor-intensive and costly process. A permanent sampling grid is a permanent network of fixed stainless steel tubing that's secured on the downstream side of your SCR catalyst. You can see one of the test ports in the top picture there. There's multiple test ports that capture this data, and a manifold port The test ports on the outside of the unit allows for ground level access for tuners. You can see that in the middle picture. The permanent sampling grid requires no lift to tune. It minimizes how much time is needed for tuning personnel, and it reduces ammonia consumption with superior tuning. This is a great way to solve issues caused by too much ammonia in your system, such as salting and permit levels at the stack, and you're saving money on the ammonia as well. It's kind of a win-win. You can make that investment. Here's a sample design of a permanent sampling grid system. Note that the testing ports have a number and letter grid system with corresponding ports in the manifold there on the right. This is how the tuners can identify which zones to tune and how to tune them. Fin tube efficiency is also critically important for a different reason. It's important for the heat transfer and steam production at your facility. Obstructions in the fins, such as rust, salting, insulation, and refractory, could decrease heat transfer and increase back pressure. Dry ice, or CO2, as it is commonly known, is utilized to clean the tubes to remove contaminants, therefore improving heat transfer and back pressure, and also increasing your production potential. Dry ice sublimes on contact when it's blasted and creates no waste byproduct. It also doesn't profile your surfaces. Another very popular cleaning tool that Groome utilizes is foam. It is the system of choice to use on fin tubes and fin fans for three main reasons. Foam is environmentally friendly, as it is biodegradable. It is asset friendly, as it's gentle on the fragile fins. And third, it is cost friendly, as it's not labor intensive. You can see the foam here being the hero of the project. We don't need a ton of men or lifts or anything costly to get this work done most times. The scale of increased cooling potential at your plant is huge. Foaming is easy to try out since you can take a few banks of fans down at a time and have them back running quickly once the cleaning is complete. Last but not least, Groome has been applying high performance coating systems in harsh environments for the past 40 plus years. We not only make your plant run more efficiently, but we can also make it look better. Calls for any coating applications ranging from your tanks, anything from D-min or oil tank, to siding, to safety markings. I thank you all for your time. As I mentioned a few times in the presentation, you're welcome to stop by our virtual booth anytime during the RefComm virtual show. Please take a moment to take my information down if you wanted to reach out to me one-on-one. We're always happy to work for you. Thank you very much for your time and have a fantastic day.